Hello, everyone. Welcome to our webinar, Building an Enterprise Unified Namespace to Power Your Smart Factory. It's a pleasure to have you all. I'm happy to introduce you all to our speakers for today, Ian Scarrett, who is Head of Marketing at HiveMQ, and John Harrington, who is the Chief Business Officer at HighByte. Accompanied by Ian and John is Aaron Sandley, who is the CTO of HighByte. He will be helping us with the technical questions. Before we kick off the webinar, I would like you all to know that we will be recording this session and all participants will be on mute. If you have any questions during the session, please type them in the QA box in the control panel. We will answer them during the Q&A and at the end of the webinar. If we cannot answer them all, we will answer them later on our HiveMQ community forum. Also, we will share the recording of the webinar and slides in a follow-up email. And we will be running 2 polls during the session. Kindly participate and provide feedback. And without further ado, I will hand it over to Ian. Welcome, everyone.
Great, thank you, Jayashree, and welcome everyone to our webinar about the Unified Namespace. We're really super excited to have John Harrington from HighByte here with us to take us through some of the key concepts for the Unified Namespace. So just briefly for the introduction, we're going to do kind of quick introductions of HighByte and HiveMQ. John's going to be doing the bulk of the webinar and talking about the concepts around the Unified Namespace. And then we're going to conclude at just kind of very high level about how HighByte and HiveMQ can work together to implement a Unified Namespace. So with that, I'd like to just kind of do a brief introduction to HiveMQ if you're not familiar with it. HiveMQ is a software company based in Germany. We're based just outside of Munich. We provide an MQTT platform, which what we're doing is we're helping customers move data from to and from their connected devices. And kind of their core competency or core values is that we do that in a fast, efficient, and reliable manner. And we'll talk a bit more about like that in the past, in kind of near the end. We have lots of customers in production, and we've got a number of good brand name customers from automotive OEMs to other manufacturing customers. Next slide, please, John. So really what our customers are doing is 3 things. We have a number of customers that are building new digital products, be it drones that fly medical supplies across cities, to industrial dishwashers. We have customers that are improving their customer experience. For instance, we have a connected car app by BMW or Audi that is really about improving the customer experience. And we also have customers certainly in the manufacturing industrial automation area that are creating more efficient operations, kind of things like predictive maintenance, but basically how do you kind of modernize your factory and create more efficient operations. And this is really where we come in for the Unified Namespace of helping provide some of the infrastructure software for that. So I'd like to turn it over now to John to kind of give a quick introduction to HighByte and then also go into the Unified Namespace.
Great, thank you, Ian. And I'm assuming everyone can hear me. So thank you all for joining us. I'm here to talk about HighByte and the Unified Namespace. Very excited to talk with you all. This is a rapidly evolving and exciting area. Little bit of background on HighByte. HighByte is a software company based in Portland, Maine. Our mission is to provide manufacturers with data infrastructure solutions as they maneuver their way through adopting Industry 4.0 technologies and concepts, or you may call it digital transformation. HighByte as a company has a global partner network across the globe of both distributors, system integrators, and technology partners. And we have a customer base which also goes across the globe and in many industries, including food and beverage, pharmaceuticals, pulp and paper, industrial products, consumer products, energy and mining, and many more. So it's exciting times for us at HighByte. So as Ian said, we're going to jump right into what is a unified namespace. Before we do that, Jayashree, can you do our first poll question? And we'll give people a minute to answer this, and then we'll take a look at the results. It's always good to get a good feel for where people are at before we start the presentation. Hopefully most people will have answered by now. Great. Excellent. So it sounds like a few people are pretty familiar, but generally people have heard the term, but they're looking to learn more. So that's very exciting. And for those of you who haven't even really heard the term or are unfamiliar with it, hopefully coming out of this webinar, you'll be much more familiar. You'll have some ideas. And for those of you planning your architectures, we look forward to working with you, and we look forward to hopefully pushing the needle ahead on your ideas and plans after this session. Okay, so let's get into it and talk about a unified namespace. But let's start off really by talking about what are the challenges that are driving the need for a unified namespace. And really that comes down to what's going on in our manufacturing environments and technology landscapes that have been happening over the last few years. I think a lot of people have heard the term Industry 3.0 and Industry 4.0, or the fourth industrial revolution. Industry 3.0 was all about process automation and automating our facilities so that they can produce manufactured goods, or they can execute whatever needs to happen in an industrial setting. And so with Industry 3.0, it was all about connecting up our data in a stack. So we started with the IO, move it to the machine controller PLC, through a connectivity solution up into SCADA or MES. Once in a while, we would also push it up into the ERP, though that was fairly limited. And again, it was really focused on that control. It was keeping the data within the operations team and really focused on how do we control the factory most efficiently. With Industry 4.0, what we see is an evolution into a lot more data moving around our companies. The data is being exposed and utilized in a much broader way through many more business functions within the company. So anyone from R&D to quality to asset maintenance to even supply chain or finance and accounting may want to get access to that industrial data. All of those job functions brought with them their own systems. So now we need to push data into these systems to get them access to it. So we see a lot more systems looking for data. In some cases, we even need to add additional data on the factory floor with smart sensors or gateways to be able to collect that data and push it up. But we're using all these cloud platforms and analytics, IoT, data lakes to provide this data access to these different job functions. As you can see, as we've evolved, this has been a project by project approach. And in many cases, each system made connections to the source data that it needed. And you see a lot of these one-to-one connections. What companies also found is that as they were ingesting data into these systems, they needed to transform that data because a lot of times it wasn't prepared the way that that target system needed it. And so they were doing a lot of custom programming, utilizing APIs. Of course, people say we're in the era of APIs, utilizing the APIs to transform that data and ingest it into the target system. No one engineered and planned for a view like you see here in Industry 4.0. In fact, a lot of people are struggling with it today. With all those connections, the administrators are finding that the systems aren't scaling. It's very hard to scale, and they rapidly are just focusing on the highest value connections because it's time consuming, it's expensive, and it takes a lot to maintain. They're writing a lot of custom scripting which is slowing things down, and it's also creating technical debt. Every time you write a program that assumes that the data coming into it is static and is defined in a certain way, if that source data, which in our case is the source machinery on the factory floor, ever changes, then we end up having to rewrite all those integrations. So the more integrations you have, the more effort you need to put into fixing them and maintaining them over time, which isn't a recipe for success. We're also finding that even though we're trying to make data available to everyone, people like data scientists report that they're spending a vast majority of their time actually looking for data and not performing their analysis. So we need to accelerate that. We need to get them the data and get them spending more time analyzing the data and less time trying to find it. And our OT team is reporting that they're spending a lot of time trying to support all these integrations, trying to explain what all that data means, when what they really need to be focused on is executing the factory and keeping the factory running and producing goods. So all these challenges have really got people to rethink how they integrate data on the factory floor. So we've come up with a couple different design patterns that we're seeing of how people are solving this. The first design pattern is what I call the hub architecture, or the integration hub. You've got lots of systems, you've got data that needs to move around. Instead of having all those point-to-point integrations, we can just move all the data into a hub and then it can route the data out. This is a very controlled approach where you're ingesting the data in a central location, you're streamlining the data flows out. Hopefully, if you're using a good integration hub, you're able to use a codeless integration capability, so you're not having to custom code things, and you're reusing your data transformations. But ultimately, you've got one central hub that you're pulling data in and then pushing it out to the target systems. Another design pattern that we see is companies have taken the approach of leave all of the execution systems integrations in place. But for people that want to analyze the data, let's just move it into the cloud. So they create a data lake in the cloud in one of the big, Microsoft Azure, Amazon Web Services, and they create a data lake in there, and then they start ingesting data in there. Now, if you wanted, what we're seeing is companies that are doing this right and are finding a lot of success with this are actually using an integration hub on premise to ingest that data from the different systems, curate the data, something that the OT team can contextualize and curate the data and then push it up into the hub. This provides you the ability to govern that data and standardize it when it goes into the hub and organize it. That way, when people look in the data lake, they're able to get easy access to it, understand what they need, and put it to use. The third design pattern that we see is the unified namespace, and this is what we're going to spend the majority of our time today talking about. So with the unified namespace, we're using a central location where the systems can publish data in and other systems can look at that data, subscribe to it, and pull it out. We need to utilize a highly scalable technology behind it. And we need to, if we're doing this well, we need to provide consistent and standardized data structures into the UNS so that people can understand what they're getting at and pull that data out. And the advantage is that with a UNS, you can easily traverse the structure and subscribe to whatever data you need. So what is a unified namespace? When we looked at for the definition, what we came up with is it's a consolidated and abstracted structure by which the business and industrial applications can exchange industrial data. So very focused on industrial data and very focused on, this is a very non-technology focused definition. What we've seen in practice is that MQTT is the overwhelming technology that people are using to deliver on this unified namespace. So if we break down that definition and think of MQTT as the underlying technology, when we talk about a consolidated and abstracted structure, we're talking about using an MQTT broker. Therefore, all of the data can be consolidated in that broker. It's highly scalable. they're open, and they're secure. MQTT also has the ability to organize data in the broker using a topic structure. Now, this is like a folder structure that you see in your Explorer on your file system. And it's with this topic structure that we're able to organize our data. The other component is we need to be able to exchange industrial data. So with MQTT, it's a pub-sub data transfer approach. So the source applications can publish data in, and the subscribing applications can subscribe to data and get the updates whenever the updates are published in. And finally, what we're moving around is actually data payloads. MQTT has this concept of a payload where you can create a complex set of data. You can utilize standard information models, maybe some that are available via various industry groups, or you can customize your payloads specific to the use cases that you're trying to solve for. And we use these payloads to normalize and contextualize and consolidate the information. So if you think about what it would look like, we now have all of our systems on the left and on the right, and we've got an MQTT in this broker in the center, which has the topic namespace with its payloads. You can publish the data in, subscribe to the data coming out, and we've got this secure and enterprise system to be able to wrap that data. Now, when we applied this to an industrial environment or a manufacturing company, we found that there were some challenges implementing this. Number one, a lot of our systems are still not using MQTT. So we need some way to be able to get data out of systems that don't support MQTT and get that data into the system. We also have found that for some of the systems that do, typically like the sensors and whatnot that publish MQTT data, they don't provide the tools to really dictate exactly where that's going to go and what that topic structure is. They also, in many cases, people want to contextualize that information. So the sensor may have the raw values, but maybe I want to pull some data out of my asset maintenance system or out of my MES system to augment that value. Well, if all we're doing is having that sensor published directly, and that becomes a challenge. We also need to standardize the data. A lot of times, data from different machinery or different sensors or different systems structures the data differently. It describes it differently. It may look very common for a human looking at it, but if you're programming against it, it becomes very hard. So if you're trying to run analytics or dashboards against it, you want it to be identical. You want the name to be identical in the name value pairs. We also need to describe this data. As we're moving the data from the OT domain into the IT domain and giving it to the business functions, we need to describe this data based on how those business functions think about it. The nomenclature that they're used to using, not what the PLC programmer thought was a good name for it. And finally, a lot of our target systems also don't support MQTT. So this MQTT broker is a great core to our unified namespace, but that's not the only component. What we're seeing is if we add an intelligent gateway at the front end of that MQTT broker, to be able to support multiple OT and IT protocols, consolidate the data, model it, then publish it into the broker, now all of a sudden we have a highly structured broker. Now we're able to get data from many different systems into the broker. And now we've got some governance on the data going in. So it doesn't become, everyone's fear, which is a big swamp of information that no one has control over and no one has ownership of. Now it's a highly organized and engineered area that people are putting highly valuable data. But we still have a few remaining challenges. Well, you can also use that same intelligent gateway technology on the outbound for those applications that don't support MQTT or they need to restructure the data again. So it's this combination of the intelligence gateway on the inbound, the MQTT broker, and then the gateway on the outbound that really provides us our unified namespace in a highly functional enterprise-ready approach. So let's talk more about the unified namespace, and let's define and dig a little deeper into what it is. A core part of the unified namespace, as I had mentioned earlier, is the structuring of the data, the organization of the data. If data is not organized, people aren't going to be able to find it. So with MQTT, we've got this concept of the topic path, and the topic path provides a way of organizing data within it. And what we're seeing and advocating within our customer base is utilize the ISA 95 hierarchy. It gives us a great logical organization of information. So in ISA 95, they define the hierarchy of data as the company, and then a site, and then area, line, and work cell. Now we always push it a little bit deeper into asset and sensor, because you may want to actually capture data at any level there. So the key with the topic path is that you can put data payloads at any level. And then when people come in, they can go in, and maybe if they're looking for things like the line OEE, they can go straight to the line area. If they're looking for area information, they can go to that. So what does that look like? Well, the payload is where the real value is, where the values are that you want to get access to. So a payload is a discrete set of information that's correlated in time or event synchronized. So in general, we collect all this data and put it into the MQTT broker all at one point in time. This could be a single value, or it could be a long, extensive set of values. It's really up to what you're trying to solve for, what the use case and the systems that are consuming the data. So in many cases, the payload is dictated by the use case and by the system that's describing. So it's important to consider them when you're defining your different payloads. Now, I've just listed a few examples here. At the site or area level, you may be doing things like looking at profit and loss. You may be looking at schedule. At the line level, you may be looking at OEE or lot data or electronic batch records. At the cell level, you may be looking at compliance or quality, compliance of the manufacturing process for the item. Maybe it's a pharmaceutical, or it's a even pork values vehicle. And then at the asset level, you may be doing predictive asset maintenance or power consumption. So the key is to identify the use case and then identify the payload of information that you need in order to solve for that use case. Now, another key concept of the unified namespace is governance. And governance is critical. It's critical whenever you're dealing with when you have large amounts of people that could be submitting and publishing information, and lots of people that may be looking for access to that information. The governance is what provides us the control of the publication of the data. And we really need to focus on consistency of data and reliability and usability of data. It's important to define standard structures. They become your data payloads, but then replicate them across the different machines, the different lines, the different sites. And that way, it's those standard structures that are highly predictable that the dashboards and the analytics and the users can depend on. Another key thing is who's able to make these changes. Well, to identify who's your team, who are the users, what roles do they have? And from a system perspective, we have to make sure that we're able to log what changes are made, and then we're able to roll back to certain baseline points so that we can reset if inappropriate changes are made. Because we have to remember that our industrial environments are constantly changing. For one thing, access to all this information, one of the core reasons for it is so that we can actually make change on the factory floor and make it more productive. Another thing is that systems get old, systems get changed, and with analytics, we're seeing a lot more change than we've ever seen in our industrial systems in the past. Analytics today may be looking at one thing, and over time, as you learn about that one piece, you extend it and you add more data, and you may get rid of some of the existing data. So it's important to keep track of all that. Now, another key thing that I've been talking about a lot is, what are the use cases? The use cases really drive our UNS. We package up data based on the use cases that we're trying to solve. These are typically driven by the systems that we need to provide the data to. So here are a number of use cases. These are ones that I hear about from our customers and our prospects daily. But you may have other use cases that you're trying to solve for. I've just pulled together a set of things that I've heard. But really, it's any challenge that you're trying to solve, any data that you need to move between systems. You define, this is the data payload, this is the data set, this is the use case that we're trying to solve for, and then you start, you work that into the UNS. Now, we've talked about what goes into a UNS, but how do you set one up? Well, the first thing you need to start with is the infrastructure. As we said, you need to start with an MQTT broker, and then you generally want to use an intelligent gateway to drive the data into the broker and to pull it out when needed. Once you've defined that, you want to define your structure. As I said before, we often use that ISA 95 structure, but you certainly need to define the structure that you're going to use as a company. Then you want to define the use cases. Where do you want to get started? When you define that use case, you need to look at what data do I need to satisfy that use case, and then start to think about, well, what source systems can I go to get this data? They become the source systems are on the left side of the UNS, and the target system is on the right side. So you need to think about, well, what are the target systems, and what requirements do they have in terms of data structures, in terms of context, in terms of frequency of updates? What we see is that a lot of analytics need very infrequent updates, maybe once every 10 minutes. But then there's some that are actually collecting data at millisecond or even multiple microsecond resolutions. So understanding what you're trying to solve for and where the data is going is critical to delivering on the UNS. And finally, the UNS you can iterate with. This doesn't have to be a big bang, we're going to implement a UNS for our entire company all at once. In many cases, people will start with a single use case. They'll define that, they'll source the data, they'll structure it, and they'll deliver it to the target through a UNS. And then they'll go to 2 use cases, and then they'll go to 4, and then 8, and you just grow it over time. Some people are starting with a data integration that doesn't exist today. Some people are starting with a data integration that causes a lot of challenges. This is a challenge, it's constantly broken, let's just replace it with a UNS, and then we can grow over time. The key with this technology that we're working with these days is that you can make changes over time and you can iterate these projects. You don't have to wipe out all of your integrations on day one in order to get value out of the system. So where do people see the benefits of using a UNS? This seems like a lot of work. Well, it's really about accelerating our business teams, accelerating data to them so they can solve the challenges that they've been hired to solve at a much greater level than they've ever been able to do in the past. We need to make data highly accessible. People now need to be able to see data, whereas 5 or 10 years ago, they would get a report weekly or monthly as to what was produced or what were the quality measurements for the period. Now they want to know on a daily, hourly, minute-by-minute basis, how many defects are we creating on each machine in each line? And they want access to that data. So we need to provide them access to the data that they need. We also need to simplify our integrations. As we saw from that early slide, we have too many of them and we need a new structure. And the UNS provides that structure. And the UNS also allows you to distribute the effort. So instead of moving all the data into an IT system and having the IT engineers try to make sense of all this OT data and try and sift through it and have a number of meetings with the OT team to try to understand what's going on and how do we make use of this, well, now we can provide a solution to the OT team to actually contextualize and assemble the data from their systems and then publish it to the UNS. And then anyone in the company can get access to it. So we're really providing agility to the factory, because as they make changes to the factory floor automation, they just update their gateways, and the data will just fall into the exact same slot that it was in the UNS. With the old assets, the new assets will fall right into that slot. So you don't need to change things out, and you're highly agile, and it just becomes part of your change management process. And with the UNS, you can leverage open standards and off-the-shelf products, and that's what Ian and I will talk about in a minute. So really, it's about making data highly accessible to the people that need to get access to it. The last section we're going to talk to here is about the products. So I'll talk a little bit about HighByte, and then I'll turn it over to Ian to talk some about HiveMQ. So we ended with our architecture of all of your existing systems, publishing data into an intelligent gateway, which then goes into the MQTT broker, out through the gateway or out directly to the systems. So HiveMQ provides the MQTT broker, and HighByte provides the Intelligence Hub as an intelligent gateway. A little bit of information about the HighByte Intelligence Hub. So this is a data hub that's designed for the industrial environment. The data hub is able to ingest data from different systems, OT protocols and IT protocols, from your OPC servers, from your PLCs that communicate over OPC, any sensor over MQTT, from your systems, your MES system, maybe over SQL, or your ERP system over REST. We can consolidate all that data in and then push it, in this case, into the unified namespace. But as we're doing that, at the core of the Intelligence Hub is a modeling engine that allows you to create those models for those use cases that we described are in the unified namespace. So we create a model for the specific use case, and then we publish that into the namespace. And we use flows to control the flow of data up into the UNS. It can also be used to pull data out of the UNS and deliver it to systems that don't support MQTT. So like if you've got a SQL database or ERP system that we want to publish data back out to, we can easily subscribe to data in the UNS and then publish out to that system. The Intelligence Hub was designed for the OT team to use. It's not a series of libraries that you code against. It's an application. It's an application that's web-based, and it provides a completely codeless interface to be able to ingest the data as well as transform it. In fact, here you can see a few screenshots. We've got lots of videos on our YouTube page. So if you go to YouTube and search on HighByte, you can see lots of videos of this in action. And at the end, we'll provide my email address. We'd be happy to show you a demonstration of it. So to wrap things up about HighByte and the Intelligence Hub, this was designed for the OT team to expose their data to the enterprise. It's designed for industrial data and to the scale that our industrial enterprises are typically working in. It's highly secure and fast to deploy. And it's a low-cost solution that you can use within your factory today. With that, I'm going to turn it over to Ian, who's going to talk a little bit about HiveMQ.
Great, thank you, John, and thank you very much for a great introduction to the unified namespace. I think it was kind of really good information for the crowd here. So for as John's mentioned, HiveMQ is an MQTT broker. We like to call it an enterprise MQTT broker platform that kind of will scale out to meet kind of the demands of most IoT and IIoT use cases. So at the core of the platform is a broker, an MQTT broker that will operate in a clustered mode, in a cluster environment. And that's where we get our scalability and high availability. If I'm going to talk a bit more about that later on. with the broker, we have what we call our control center that basically is a dashboard that kind of allows you to monitor the health of the platform, but also more importantly, can provide some level of observability in terms of the clients that are connecting to it. So on the left-hand side, the devices will connect to the broker. These would be the MQTT clients, or in the case of the Unified Namespace, it could be the HighByte Intelligent Gateway. And then we also have the ability to integrate into kind of enterprise services with an enterprise SDK. We run on a kind of a wide variety of platforms. You could kind of host it yourself. You could host it on AWS. You could host it on Azure. We actually also have a managed service ourselves, or managed cloud service. What I want to do, so it's the next slide, John, please. I also wanted to go in and talk a bit about how we see people deploying the broker in a multi-factor deployment. So this would be a more sophisticated unified namespace where potentially you'd have a unified namespace isolated within each factory. So a broker in each factory. But what we're seeing more and more is that people also want to be able to collect information from each factory into our corporate data center and have a unified namespace in the corporate data center. And for this reason, we provide what's called a bridging technology for MQTT broker bridging technology. And that allows you to easily kind of basically move data between each factory up to the data center, but more importantly, kind of moving data back down into the factory by connecting the brokers. And really, it's a federation of brokers that you get. We even some more complicated deployments, we'll see that even within a factory, like a large factory, they'll put a broker at each line for each line too. That is potential too. So you can get kind of really sophisticated in the deployment of these types of unified namespaces. And I think that's really kind of one of the key things is the flexibility that this types of architecture provides, that you can actually start with one factory and then grow into multiple other factories, but also connecting into a data center. So next slide, please, John. So I just want to talk briefly about kind of what makes HiveMQ unique in amongst the MQTT brokers. And we really believe that we scale into the millions. We actually have one client that actually has over 250 million MQTT clients connecting to a clustered environment of HiveMQ brokers. So scales quite substantially. But scaling is also not just the number of devices, it's also message throughput. And we can scale well into the very high throughput environments. The next area is that kind of our support for business critical reliability and high availability. And this is one of the key reasons why people come to us in terms of using HiveMQ as their MQTT broker, that we are able to basically set up in the HA environment, in a cluster environment where essentially if a cluster node goes down, the connections that the devices that are connected to that node automatically get rolled over into the remaining cluster nodes, right? And this basically kind of guarantees that your devices always have a connection there. So if you require extremely high availability, kind of business critical reliability, HiveMQ can provide that type of cluster environment that you need. We also provide, as we said, a control center or a dashboard that provides kind of very kind of detailed level of observability. So if you've deployed kind of a number of MQTT clients out into your factories, or if you're doing remote asset management, if one of those clients is not behaving properly, how do we provide the tooling so you can kind of troubleshoot and diagnose what's going on with those clients? And this is really important because if you kind of often an MQTT system can be a black box to people. So you need to actually be able to go in and kind of see what's the message flow, see what topics the client's subscribing to or not subscribing to. The other areas that we are unique is our SDK that we talked about, and also the freedom to run anywhere. We basically provide an on-premise version and cloud versions, which is important, right? And if a factory you want to deploy on-premise, we allow you to do that. But if you don't want to be concerned about managing the infrastructure, the software infrastructure, we also have a cloud version that you can use too. So you get the freedom of choice. So that's really where we come in from the unified namespace, is providing this enterprise level MQTT broker that's scalable and reliable, and really provides the tooling you need to be able to manage the deployment once it's running. So that's a really quick synopsis of HiveMQ. I think we've got lots of time for questions. So we'll turn it over to kind of ask John and Aaron to come in. And please ask the questions not in the chat, but in the Q&A. That's where I'm going to kind of pull from for the questions. It just makes it a lot easier for us to kind of have it from one location. So the first one is actually from Richard Shaw. Does HiveMQ understand Sparkplug payloads can peek inside or just pass it along? So right now we just pass it along. We're just kind of it's a public subscribe of the Sparkplug messages that will pass it along for things. Actually, sorry, I forgot to mention we're going to run a poll during the Q&A, so please take some time to answer the poll as we go through the Q&A.
Hey, Ian.
Yes. Yep. Yep. Go ahead.
Just so we can answer that on the
Sure.
HighByte side.
Yeah.
HighByte can both publish and subscribe to SparkPlugB payloads. And if you subscribe to SparkPlugB payloads, we can see inside the payload and break it out so that you can break out if you got multiple values in there, you can inspect and then pull out the individual values and make use of them within HighByte and then publish them into the Hive broker.
Yep, great, thank you. So there's a question, can HighByte be used for enterprise UNS also? I think so, John, I think the answer is yes there, but if you want to elaborate on that.
Well, so HighByte is not a broker in itself, and people are not able to subscribe to data in the HighByte namespace. So that's why we would work with Hive, and we would publish data into the Hive namespace, and then people could source it from that. And by working with someone like Hive on an enterprise, they give you the scalability and the clustering and all that sort of thing that you would want for an enterprise broker. So HighByte unifies the namespace and then publishes up into the Hive broker for people to subscribe to the data.
Okay, and so another question for you, John. You mentioned that the team that is responsible for creating and maintaining the unified namespace, the structure and the content. Can you expand? What roles, responsibilities, parts of the orgs are engaged?
That's a great question, and it's actually evolving over time, and we're all kind of learning this. We're seeing the OT and IT in some companies, the operations tech team is merging with the IT team. In other companies, they're working together. I had one conversation with a director of an OT team who said his biggest challenge was getting his team to recognize that IT was their customer and no longer their adversary. So these are changing over time. We're also seeing a lot of OT teams either hiring people or working with the IT team to provide experience on infrastructure, on architecture, and on data engineering. But in general, it's the operations technology team, which is generally made up of people like controls engineers, process engineers, SCADA engineers who really understand those data points. It's those people that are able to contextualize the data and are able to bring uniformity and standards to the data. So those are the people that are generally working with the Intelligence Hub to define the structures and then publish the data into the broker. And they're the ones that are generally also making changes to the source data. And so they need it in their change process to also update the integration system, update the Intelligence Hub with any changes that they made so that data, so you don't lose data for a period of time. So those are typically the roles. It's often on the OT team, though it's all in collaboration, because we also see some companies, they're defining an enterprise team that defines kind of the data governance. And then it's the OT team at the local sites that are going out and implementing the technology and implementing the actual data transformations. I don't know if Aaron or Ian, you have anything else to add.
I think that was great explanation. Aaron, do you have something?
Nope, I'm typing away on the chat
Okay.
trying to answer other questions. So
Okay.
I apologize, I wasn't listening. Yeah.
Nice. Good, all good.
I'll give you another one, John. You're on a roll here. So a model in HighByte is simply a set of data that you're collecting from the unified namespace.
Yeah, a model in HighByte is a set of data, a payload of data. It could be collecting from the unified namespace, or it could be collecting from other systems to be published into the unified namespace. So within HighByte, we can ingest data, consolidate data from multiple sources. The model allows you to standardize it and unify it and add context to it, and then publish it to the target. So the target in many cases is a unified namespace, but it could also be another system.
Okay, great. I'll take this one. So with respect to HiveMQ, what are the limits, number of topics, throughput, et cetera, for a single instances running in a single server machine, not a cluster? So there are no hard limits. It really depends a lot on the use case and on the environment it's running. And so it depends on the message payload size. It depends if you're using security or not. It depends what level of service, kind of quality service level you're there. I can tell you that you can certainly scale up to a reasonable size system with a single instance machine. And get a fair number of throughput from it, but you don't get the high availability that many people are looking for. And certainly, everyone, feel free to ask follow-up questions as we go through. Let me just see. Let's try this one. It's rather long. So would MQTT and Unified Namespace be a better option to connect MES with ERP? MES with other productions need to get lots of info like bill of materials, material availability from an MES. These are high payload cases, and I don't know where MQTT, HiveMQ, Unified Namespace, and HighByte would fit in here. Aaron, I know you're typing an answer, but John, do you want to kind of take that from a? Aaron,
did you want to say something, or you get?
I'm typing. Yeah. So the answer is yes, but there's a caveat, right? And that's what I was typing out. The UNS concept today is very much report by exception, right? And when you get into like MES and ERP systems, not all of those interactions are report by exception, right? You might have a transaction like you want to go get the bill of materials for the current day. So I think the UNS space is evolving to take on those use cases. But if you looked at the market today and where it is, that would be more of a difficult thing to accomplish with a traditional, HiveMQ broker and HighByte. So I think the answer is yes, but a little more time. But certainly, those systems mixing manufacturing data with data from the MES and ERP, that's definitely in use today. But when you talk about connecting those two systems, ERP and MES, that transactional piece is missing today, but evolving pretty quickly.
And Aaron, this might be a good one for you too. If I want to get data in Azure, what would be the preferred route to take? I see both HighByte and HiveMQ seems to be able to do it. Is there any disadvantage of using a unified namespace approach anyone can think of? So actually that's two different questions. So first is kind of, they want to get data, I guess, into Azure. Do you want to take that? What would be the preferred?
Yeah, so the good news is you have options, right? So you could use HiveMQ or HighByte. So it more depends on your architecture and how you set that up. Do you want your factories to publish to a HiveMQ broker, and then from the HiveMQ space, you'll pick off the data points that you want to go into Azure, or is it you want that control to be more local, and from the local site, you want to be able to push up into Azure? You could use HighByte in case, or in the first case, you could definitely use HiveMQ to kind of push that data into IoT Hub. So it more depends on your architecture, and a lot of times with our customers with proof of concepts when they're just starting out, and I can't speak to the HiveMQ case, but it might be easier just to push from HighByte into Azure to kind of prove the concept. And then as your architecture evolves, it might be easier to move that over to HiveMQ. But yeah, it's really an architectural question. And is there a disadvantage of using the UNS approach? Anybody can think of. I guess that's specific to the Azure case. No, I think, when I look at UNS, like John did a great job describing it, it's this idea of we're going to change the data, we're going to change the way that data moves in the factory, and we're going to make it more open, right? Like John said, so it's more adaptable and you can make changes to it. So I think if you can start to leverage the UNS inside the factory to move data between systems and provide openness to that data, I don't think there's any disadvantage to doing that. So yeah.
Okay, great. Lots of great questions here. We'll just keep on moving along here. Do you also contextualize process data in the UNS using information stored in PLM? For example, product metadata and discrete manufacturing. John, do you want to take that?
Yeah, we can certainly connect in with a PLM system, pull data out, and then contextualize the process data. That is a key use case that I would say that we solve.
Okay. HighByte is running software, is software running on an IPC, correct? No hardware for the gateway.
Correct. You supply your own hardware. It's HighByte is a software solution. It can run on both Windows or Linux, and the customer would supply their own hardware for that.
Actually, so a OPC UA question. Maybe you guys can help with this. Some manufacturers are pushing OPC UA. How to convert from OPC UA to unified namespace? I think that's where you guys come in, right?
Right. I mean, the HighByte Intelligence Hub has a connector to OPC UA. In fact, our team, the majority of the HighByte team came from the OPC UA space. Many of us, myself included, previously worked at Kepware. So we are able to ingest that data from the OPC UA servers and then transform that data and publish it into the unified namespace. At the same time, we can contextualize it, do any transformations that need to happen.
Okay, so we'll move on here. Would it be viable to use HighByte if the OT controllers are set up according to ISA 88, or would the transparency to higher levels of the pyramid be affected?
I was just going to try and read that one.
Let me read it again. Or?
Sure, ask again.
Would it be viable to use HighByte if the OT controllers are set up according to ISA 88, or would the transparency to higher levels of the pyramid be affected?
ISA 88 is batch. I know that, but I guess,
right.
Yeah, I don't right. totally understand the question.
It's not really a protocol. So, presumably you've structured your data structures on the PLC using those batch structures defined in ISA 88. But we would need to get to the data, say, via OPC or depending on what the PLC supports and other tools that you're using. So we can ingest that data. We could certainly ingest those ISA 88 data structures and do anything that, and then publish them into the unified namespace. So I don't see any limitation with ISA 88, but I think there's more to the implementation that we would want to dig in on a little bit more. I'd be happy to take that offline if someone wanted to reach out to us.
Yeah, and we'll definitely follow up with contact information if people do want to follow up with any of the speakers.
Yeah, maybe I'll just switch that slide right now, Ian, so people can see our contact information.
Good idea. Could you provide an example of data flow from a Siemens-controlled PLC to the unified namespace into an ERP system so that quoting can utilize?
Provide an example. I mean, we can certainly do that. Many of the Siemens PLCs today, the more modern ones, are supporting OPC UA, and HighByte can connect in with them and request the data that's needed. Some of the older ones don't, and we would use either something like WinCC or Kepware or other products to get access to the data. We can then publish into the unified namespace, which can then, for that matter, we can also subscribe to that same data in the unified namespace and publish into the ERP system that they're using.
Okay.
So
this is what kind of about IoT. So about IoT strategy in start, should we start with the cloud or with the MQTT broker, which will be able to expand and scale easier? So I think kind of, so typically the MQTT broker and the cloud are can be synonymous. I think maybe what you are asking is do you want to install your broker on premise or install it in the cloud? So if that's kind of the direction we're going, I really think that's a use case decision where if you, for some reason, don't want your data to leave the factory for privacy, for security reasons, if for latency reasons you want to keep your broker as close to the factory as possible, then you would probably start with on premise. If basically you don't want to be worrying about managing software in your factory, you want other people to be worrying about managing the broker, then a cloud offering would certainly be better. From a scalability and expansion perspective, they both will scale as you kind of add either hardware requirements to scale it up, or kind of a clustering environment to scale up. So from a scalability point of view, they're both, it's still a very similar process. So so hopefully that did answer the question that you're looking for. How much resources does HighByte require, or as in recommended CPU, memory, hard drive space?
Good question. Hard to answer because a lot depends on the amount of data that you're flowing through it. As a base system, we don't require much at all. We require, a single processor and a few hundred megabytes of disk space and a small amount of RAM, a gigabyte of RAM or something. Clearly, the more you scale up your system, the more we're going to scale and consume the resources on that system. So if you've got multiple processors, high volumes of RAM, high volumes of disk space, the disk space is primarily used when you enable store and forward. So we have the ability to buffer to disk if we lose connection to the target system that we're publishing it to. So this comes in play a lot of times when people are moving data to the cloud or to a remote data center. You may lose connection, we can buffer it to disk, and then when that connection is established, we can publish it up. So if you're doing a lot of that, then obviously disk space is needed. But something that we'd be happy to, on our website, we've got some information on minimum requirements, but we'd be happy to set someone up with a trial where they can scale it up and understand the scale and scope of their deployments, and then give them some advice.
All right. Just kind of, there's a number of questions left, and I'm not sure, unfortunately, I don't think we're gonna have time to get to them all. We will try and follow up as much as possible with the other ones. Let's just see here. Kind of the ways there's a question about the hardware specs that I think you just answered in terms of the capability for HiveMQ. It's certainly depend on the use case. Right. We do actually, I don't have the hardware specs right in front of me. We do provide a minimum set of requirements, which is pretty standard in terms of it's not a significantly big piece of hardware that you need. So we can certainly follow up with the specifics of that.
Hey, Ian, there was
yes.
one question here about I'll call it the invention of the unified namespace, and I'll give a shout out. I'll give a shout out to the team at Intellic Automation and Walkarounds and Industry 4.0 Solutions. They certainly have. I think they certainly coined the term. They were one of the early people that were playing with the concept, and we've worked extensively with them. They do a great job. we bounce ideas off each other frequently about how to implement it. What are some of the technologies? What are different techniques? What are we hearing? So, you know, they certainly deserve a shout out on an event like this, because they've done a great job of promoting this concept and helping to define it. And I think we all enjoy working with them, and they've got a great Discord channel that is collecting a lot of people to talk about these topics and get the word out. So
yeah, I was gonna
just
add,
wanted to mention that.
yeah, absolutely. And I was going to mention the Discord channel. It's a great community to interact and ask questions on. If you have more detailed questions about the unified namespace, I highly recommend it. And the Industry 4.0 YouTube channel is very prolific in terms of providing really good quality content there too. So we're at the top of the hour. So I think we'll call it a wrap there. So thank you everyone for attending. Thank you for the great questions. Lots of great interactions there. John and Aaron, thank you very much for kind of coming and joining us with this webinar and putting on the webinar for us. I learned a lot, so thank you very much. All right.
Thanks for inviting us. It's been a good time. Thank you.
Take care.
We'll talk to everyone later. Bye.
Bye-bye.